A popular video about the NLAW made a claim, in its title, possibly in its body content, that the weapon is thermobaric. The comment section found out. The top comment demanded, "Get it right." 40 people liked to reply saying flatly, "It's not a thermobaric weapon." Another 37 endorsed, "It's not thermobaric though, is it?" Comment sections don't prove anything on their own. But on this specific question, those commenters were right. The NLAW isn't thermobaric. It was never thermobaric. And the distinction isn't technical pedantry. It goes to the fundamental physics of how this weapon kills tanks, which is the entire point of the weapon existing. One thing worth flagging before we start. No transcript of the original video was available when this script was written. It's possible the video corrects itself internally and only its title is misleading. The comment reaction is documented regardless. So this is the video where both the title and the content are accurate. The NLAW uses a heat warhead, not a thermobaric one. Those are categorically different kill mechanisms, designed for categorically different targets, working through categorically different physics. To explain why calling one the other is wrong, you need to understand both. Start with thermobaric, because you can't prove what something isn't until you've properly explained what that thing actually does. Thermobaric weapons work through a two-stage process, and the first stage is what gives them their unusual properties. An initial explosive charge detonates, rupturing a container and dispersing an aerosol cloud of fuel into the surrounding atmosphere. The fuel is typically finely powdered metal, hydrocarbon-based liquids, or organic compounds. That aerosol cloud doesn't simply expand in a sphere. It flows around obstacles, seeps around corners, pushes into enclosed spaces through every available opening. It mixes with atmospheric oxygen as it spreads. This dispersal phase is critical. The weapon needs that oxygen mixing to complete the process. Then a second charge ignites the cloud. The result isn't the sharp, instantaneous spike of a conventional detonation. It's a sustained, expanding pressure wave, a prolonged blast consuming atmospheric oxygen and generating fireball temperatures of 2,500 to 3,000 degrees Celsius. Overpressure from thermobaric weapons reaches 1.5 to 2 times higher than conventional explosives of comparable size. In specific documented configurations, overpressure has been measured at the equivalent of 1,000 pounds per square inch. That sustained pressure wave is why thermobaric weapons are genuinely devastating in enclosed spaces. In bunkers, tunnels, foxholes, basements. The wave bounces off walls and compounds on itself. The injury mechanisms include ruptured lungs, burst eardrums, crushed inner ear organs, ruptured internal organs, severe concussive trauma, oxygen depletion, and burns. The lethal overpressure threshold for human tissue is clinically documented at around 153.8 kilopascals. In confined environments, thermobaric weapons can kill through multiple mechanisms simultaneously, and survivors frequently suffer severe respiratory injury, even at distances beyond the lethal radius. Russia has deployed these extensively and continues to. The TOS-1A, a 220mm thermobaric multiple rocket launcher mounted on a T-72 or T-90 chassis, was first fielded in Afghanistan in 1988–89. Its overpressure wave extends to a 150-meter radius. Its blast zone reaches 200 meters. The RPG-TBG-7V attaches a 105mm thermobaric warhead to the standard RPG-7 launcher. It weighs 4.5 kilograms, carries 1.9 kilograms of thermobaric explosive, and has a lethal radius of 10 meters in open terrain. The RPOA Schmel, the Bumblebee, is a man-portable single-shot thermobaric launcher weighing 11 kilograms with a 600-meter range. Despite being designated a flamethrower in Russian service documentation, it operates as a thermobaric weapon. These are serious, effective weapons. Against personnel in field fortifications, urban structures, and enclosed spaces, their effects are genuinely terrible. Acknowledging that properly is what makes the next point sharp rather than dismissive. Thermobaric weapons can't defeat a buttoned-up main battle tank. The physics are unambiguous. Thermobaric warheads depend on atmospheric oxygen and produce area effect overpressure, a blast wave that spreads in all directions. Modern composite and spaced armor, the kind fitted to a T-72, T-80 or T-90, dissipates overpressure by distributing energy across multiple material layers. A pressure wave has no focusing mechanism. Unlike a shaped charge jet, which concentrates energy along a precise axis, overpressure simply spreads across the armor surface and attenuates. The composite matrix of ceramics, steel, and air gaps that constitutes modern tank protection was specifically designed to defeat concentrated penetrators. A diffuse pressure wave finds no coherent path through it at all. If the tank crew is buttoned up inside their vehicle, a thermobaric weapon is functionally useless against them. Multiple technical and doctrinal sources are consistent on this point. Thermobaric weapons also don't function properly at high altitude or in adverse weather. They depend on ambient atmospheric oxygen, and if that oxygen isn't available in sufficient density, the reaction fails. The NLAW is designed to kill main battle tanks. That's the design requirement. That's the primary mission. A weapon designed to kill MBTs can't rely on a warhead mechanism that is known to fail against MBTs. The thermobaric label doesn't just misidentify the mechanism, it describes something that would make the weapon incapable of its stated purpose. So what does the NLAW actually fire at a tank? HEAT stands for High Explosive Anti-Tank. Right there in the acronym is the source of most of the confusion, because high explosive combined with anti-tank makes listeners assume the explosive heat is what defeats the armor. Through burning, through melting, through some thermally mediated process. That assumption is wrong. A 1990 technical report from the US Army Ballistic Research Laboratory at Aberdeen Proving Ground documented how pervasive the error is. Researcher D.R. Kennedy, writing in technical report BRL-TR-3142, stated that probably 9 of 10 descriptions of shaped charge heat projectile functioning are in error. The same report notes the HEAT acronym stands for High Explosive Anti-Tank and does not relate to thermal effects. 9 out of 10 descriptions. Wrong. The misconception isn't a fringe misunderstanding, it's the dominant account. Here's the accurate one. The shaped charge concept was first systematically documented by Charles E. Monroe, a civilian chemist working at the U.S. Naval Torpedo Station in Newport, Rhode Island. In 1888, Monroe noticed something. When a block of explosive gun cotton with the manufacturer's name stamped into its surface was detonated against a metal plate, the lettering was cut into the plate. The hollow impression of the letters, the void in the explosive, was focusing the blast energy along a specific axis. A void in an explosive directs the detonation force. That observation became the Monroe effect. In Europe, it's called the Neumann effect, or the von Förster effect. Max von Förster had independently discovered the cavity charge principle in 1883. The core insight: the geometry of an explosive cavity shapes where the energy goes. Now add a liner. In a modern heat warhead, a cone-shaped metal liner, most commonly copper, sits inside the explosive, facing the target. Munro's original crude demonstration used a tin can lined with sticks of dynamite, which punched through the top of a steel safe. In military application, the liner is a precisely machined copper cone with controlled grain structure and wall thickness. The NLAW's warhead contains 850 grams of insensitive munitions-compliant PBX explosive surrounding a 150 mm copper liner. When the detonator fires, the explosive wave travels through the PBX at approximately 8 km per second. As that detonation front reaches the conical liner, it subjects the copper to peak pressures of around 200 gigapascals, roughly 2 million atmospheres. The yield strength of copper under normal conditions is about 0.07 gigapascals. The liner is being subjected to pressures nearly 3,000 times its own yield strength. At those pressures, the liner doesn't shatter. It doesn't melt. At those pressures, copper behaves, to a first engineering approximation, as an incompressible fluid. The cone collapses inward sequentially, from the apex down toward the base, squirting material forward along the central axis at extreme velocity. The surface temperature of the copper jet during this process, 400 to 600 degrees Celsius. Copper's melting point is 1085 degrees Celsius. The liner is reaching only 20 to 50% of its own melting point. This material isn't liquid. The West Point reference paper on shaped charges, one of the foundational documents in this field, authored by William Walters, is precise about what the jet isn't. The jet isn't a cutting plasma. It isn't a liquefied or molten metal jet. The cone does not impact the armor intact. The jet temperature isn't 20,000 degrees Celsius. The jet does not burn its way through armor. The tip of that copper jet travels at 7 to 14 kilometers per second. The speed of sound in air is 0.343 kilometers per second. That jet tip is moving between 20 and 40 times faster than sound. The rear segments travel at 1 to 2 kilometers per second, slower. And that velocity differential stretches the jet as it travels, elongating it until it eventually fragments into discrete particles. Penetration depth decreases once the jet fragments, which is why standoff distance matters. Too close to the target and the jet hasn't fully developed. Too far and it's already beginning to break apart. For a 150 mm warhead, optimal standoff is approximately 6 to 8 charge diameters, roughly 0.9 to 1.0 meters. In the NLAW's overfly top attack mode, the proximity fuse detonates the warhead at 1 meter above the target. That's directly in the optimal standoff window for a warhead of this diameter. When the jet strikes armor, the physics enter a different regime entirely. Peak pressures in the steel plate from jet impact, 100 to 200 gigapascals. At those pressures, both the jet and the target armor temporarily behave as fluids under extreme pressure. This is called hydrodynamic penetration. The Walters paper describes the result. The cavity produced in the metal plate due to this jet-target interaction is due not so much to a thermal effect, but to the lateral displacement of the target armor by the tremendous pressures created. The target material is actually pushed aside. The armor flows around the jet. The steel doesn't melt. The jet doesn't cut through with a plasma torch. At those impact velocities, the solid steel temporarily loses its material rigidity. It yields to the pressure event the way water yields to a fast-moving object. A perforated armor plate weighs the same after perforation as before it. The material isn't vaporized or burned away. It's physically displaced. Wikipedia's entry on shaped charges states this plainly. Contrary to misconception, possibly resulting from the acronym HEAT, the shaped charge does not depend in any way on heating or melting for its effectiveness. That is, the jet from a shaped charge does not melt its way through armor, as its effect is purely kinetic in nature. Purely kinetic. That's the phrase. For the NLAW's 150mm warhead, the published penetration figure from Saab is greater than 500mm of rolled homogeneous armor. Some technical sources give a range of 400 to 600mm, depending on engagement conditions. To calibrate that number, theoretically optimal shaped charges can achieve penetration depth equal to 12 charge diameters. For 150mm, that's 1,800mm theoretical maximum under controlled laboratory conditions. The published combat specification of greater than 500mm reflects real-world variables: armor angle, explosive reactive armor packages, manufacturing tolerances, engagement geometry. The warhead is a single shot, one copper cone, 850 grams of PBX. A jet traveling between 20 and 40 times the speed of sound, that physically displaces steel through hydrodynamic pressure, not heat, not plasma, not burning. After the jet punches through the armor, three mechanisms work inside the vehicle simultaneously, and understanding all three is what separates a punched hole from an actual kill. First, residual jet energy. The jet doesn't spend all its kinetic energy on the armor. Whatever momentum remains continues through the vehicle interior, striking whatever occupies the space behind the penetration point: ammunition stowage, fuel lines, electronics, and crew. Second, and frequently more lethal, spalling. The penetration event tears fragments from the inside surface of the armor at the impact point. Those irregular metal fragments move at high velocity through the crew compartment, which is a confined metal box. The crew isn't being killed by molten copper traveling through the tank. They're being killed by fragments of their own tank's interior armor, launched by the kinetic event at the penetration point. Spall hits crew, perforates pressurized fuel lines, ignites propellant. Third, severe mechanical shock damages electronics, fire control systems, and sensitive instruments, even in engagements that don't fully penetrate the armor or directly strike crew. If spall or residual jet energy reaches propellant, specifically the autoloader ammunition stored in the carousel beneath the turret on Soviet and Russian tank designs, the result is a secondary explosion, the catastrophic kill. The ammunition detonates. The turret separates from the hull. That's not a property of the NLAW's warhead specifically. It's a consequence of where Russian tank designers chose to store ammunition, combined with the spall environment that heat penetration creates inside the vehicle. The NLAW's warhead doesn't cook a tank. It punches a focused hole through steel at hypervelocity. And what happens next inside that metal box is a function of geometry, spall physics, and ammunition stowage. With the warhead established, the nationality question deserves the same level of precision. The NLAW's comment sections carry a persistent faction war. Is it British or Swedish? The answer requires naming specific organisations and their specific contributions. because the tribal argument dissolves when the documented record is laid out. The requirement originated in Britain. In 1997, the British Defence Procurement Agency began issuing invitations to tender for a new man-portable anti-tank weapon to replace the LAW 80. The formal invitation to tender was issued in September 1999. The specification: a single-soldier weapon capable of defeating any contemporary main battle tank. The programme name was MBT-LAW, Main Battle Tank Light Anti-Armour Weapon. Two companies competed. Saab Bofors Dynamics submitted the MBT-LAW design. Matra BAE Dynamics, a joint venture that included BAE Systems, submitted a weapon called the Kestrel, derived from Lockheed Martin's FGM-172 SRAW. In May 2002, Saab Bofors Dynamics won. After selection, the programme formally became a British-Swedish joint venture, primarily led by the Defence Procurement Agency and assigned to Saab Bofors Dynamics for full development and production. The £18 million assessment phase cost was split equally between Saab Bofors Dynamics, the UK DPA, and Sweden's Defence Materiel Administration, the FMV. On BAE Systems, the company that lost the competition isn't a component supplier to the winner. Matra BAE Dynamics was eliminated in May 2002. BAE Systems' documented role in the NLAW programme is as a losing competitor, not as a contractor. Any claim that BAE Systems built guidance components for the NLAW appears to reflect confusion with the Kestrel programme, the bid that was rejected. The programme documentation does not support BAE as a post-competition subcontractor. Sweden adopted the system under the designation Robot 57, RB57 in Swedish shorthand. The UK designates it NLAW. Both militaries operate it. Final assembly and testing. Thales in Belfast. Thales's own press release is unambiguous. Thales Belfast has provided the final assembly of NLAW on behalf of Saab. The BBC confirmed in January 2023 that Thales would assemble thousands more missiles for the Swedish manufacturer under a £223 million contract. There's a test facility in County Down. The BBC described the Thales Belfast factory in 2025 as best known for the NLAW, a shoulder-fired anti-tank weapon widely used by the Ukrainian army in the war with Russia. Thales is a French-owned company. Their factory is in East Belfast. They're working under contract to a Swedish prime contractor, assembling a weapon designed around a British military requirement. Beyond Thales, Saab and Thales built a supply network called Team MBT-LAWK, involving 14 subcontractors, with manufacturing occurring mostly in the UK. The individual subcontractor names aren't in the public record, but the structure of UK industrial involvement is documented. The procurement history makes the commitment concrete. December 2022. UK signs a £280 million deal with Saab for several thousand additional systems. January 2023. Thales Belfast receives the £223 million contract for the next production batch. 2024 to 25. UK Defence Equipment and Support negotiates a further £229 million agreement with Saab. Deliveries started in 2009, and the Belfast line has run continuously since. So the nationality breakdown. Saab Bofors Dynamics is the prime designer, developer and manufacturer, a Swedish company. The UK MOD issued the requirement, co-funded development at 1/3 of assessment costs, and is the primary customer. Thales Belfast, French-owned, handles final assembly and testing. Sweden adopted the system independently as Robot 57. 14 UK subcontractors supply components. Calling it purely British gives Sweden's prime contractor no credit. Calling it purely Swedish ignores the UK requirement, the UK funding, the UK assembly, and the UK supply chain. One Reddit thread summarised it accurately, if informally. Made by Sweden and UK with French elements. That's not a clean national story. It's a collaborative programme assembled by European defence industry. The faction war is both sides being right about half the picture. Understanding why the warhead's kill mechanism matters requires understanding how the weapon actually delivers it. The NLAW uses Predicted Line of Sight Guidance, PLOS. The operator tracks the target through the weapon's sight for 2 to 3 seconds before firing. During that tracking window, the missile's inertial measurement unit records the target's apparent angular velocity, how fast it's moving across the sight picture. From that data, the system calculates where the target will be when the missile arrives, not where it's when the trigger is pulled. The operator fires. The missile is autonomous from that point. No wire, no laser, no radio link back to the launcher. The operator can immediately relocate or take cover. A significant tactical advantage over wire-guided systems, where the operator has to maintain position throughout the missile's flight. Launch sequence. A soft launch motor fires the missile at 40 meters per second. Low initial velocity, minimal backblast, operable from enclosed spaces. The flight motor initiates 8 meters from the launcher and accelerates the missile to roughly 200 meters per second. Engagement time from target identification to firing, approximately 5 seconds. Combat range, 20 to 800 meters. The 20-meter minimum deserves specific mention. It's genuinely unusual. Saab describes the NLAW as the only system capable of defeating a main battle tank from 20 meters. At that range, a conventional ATGM with a long arming distance would fail to function. The NLAW doesn't. 2 attack modes, 2 different fuse types, 2 different target sets. Overfly Top Attack, OTA, is the mode designed for main battle tanks. In OTA, the missile flies 1 meter above the line of sight. When the proximity fuse, using dual optical and magnetic sensors, detects the vehicle directly below, the warhead detonates. The shaped charge fires downward at 90 degrees into the vehicle's top surface. The standoff of 1 meter is, as noted earlier, within the optimal window for a 150mm warhead. The armour differential is the entire tactical argument for this mode. The front of a T-72, the glacis plate, carries approximately 550mm of equivalent armour protection. The turret face is heavier still. A T-90's frontal protection at its thickest point approaches 750mm equivalent. Those numbers exceed what the NLAW can reliably penetrate in direct frontal attack. The top armour on a T-72 or T-80, typically 20 to 50mm of steel. The NLAW penetrates more than 500mm. Against top armour of 20 to 50mm, that's not a narrow margin. That's complete overmatch. Overfly Top Attack doesn't attempt to punch through the tank's strongest protection. It roots around that protection entirely, attacking where the vehicle is genuinely vulnerable. Direct attack, DA mode, fires the missile straight to the point of aim, using a contact fuse rather than a proximity fuse. This mode is for soft-skinned vehicles, trucks, helicopters, crew-served weapons emplacements, positions inside buildings, and stationary armoured targets, where the operator can place the shot precisely on a weak point. The Squad Wiki documentation, which models real system mechanics, states it plainly. The NLAW can carry out an overfly top attack on an armoured vehicle or a direct attack on structures and non-armoured vehicles. The two modes aren't redundancies, they're tools for different situations. OTA against mobile armour, DA against everything else, or against stationary armour where geometry allows a precise hit on a specific vulnerability. One technical point worth noting for the ECM discussion later: PLOS guidance uses no radio frequency link, no GPS dependency. The system is passive after launch, guided by inertial data gathered in the 2 to 3 second tracking window before firing. There is no signal to jam. An electronic warfare system that could suppress GPS or intercept drone control frequencies has nothing to work with against a fired NLAW. A question that comes up in veteran and mill enthusiast discussions of the NLAW is its relationship to the Carl Gustaf, the 84mm recoilless rifle known in British service as the Charlie G. The connection is real. The manufacturing lineage is direct. The Carl Gustaf was introduced in 1946 by Carl Gustaf's Stadsgevärsfaktori, a Swedish state arms manufacturer in Eskilstuna. That company's subsequent mergers and reorganizations eventually produced Saab Bofors Dynamics, the same organization that designed the NLAW. Both products remain active in the Saab catalogue simultaneously. In January 2025, Lithuania signed a €14 million contract with Saab Bofors Dynamics for Carl Gustaf M4 rifles, with deliveries scheduled for 2025 to 26. Same Swedish engineering house, same prime contractor, different weapons entirely. The Carl G is a recoilless rifle, unguided, man-portable, multi-shot, reusable tube. The operator must aim, lead the target, and manage the trajectory manually. The current M4 generation fires multiple warhead types, including heat, HE, fragmentation, and illumination rounds. But the fundamental mechanism is ballistic. The gun is a tube, and what comes out of the tube follows basic artillery physics. The NLAW is a guided fire-and-forget missile, single-shot disposable launcher, PLOS, autonomous guidance. No operator action required after firing. A 2019 US Marine Corps thesis on expeditionary advanced base operations framed the generational gap explicitly. Wargaming exercises highlighted the need for a light and lethal anti-armor weapon more capable than the M4 Carl Gustaf. The Carl G is the established baseline. The NLAW class is what doctrine calls for when the baseline isn't enough. The shared corporate lineage is genuine. Both weapons come out of the same Swedish industrial tradition. But the engineering relationship ends there. One is a recoilless rifle. The other is an autonomous fire-and-forget guided missile. They're connected the way a truck manufacturer and a fighter jet manufacturer might be connected if they shared a parent company. The DNA is organizational. The weapons are different categories. The NLAW became globally visible in February 2022, but the UK started moving them before the invasion started. Deliveries began on January 18, 2022, 6 weeks before Russia launched its full-scale invasion on February 24th. Royal Air Force Boeing C-17 Globemaster aircraft were the confirmed delivery platform. A senior MOD source confirmed to Janes that deliveries were underway on that date. 2,000 NLAWs reached Ukrainian hands before the first Russian armoured column crossed the border. An additional 1,615 followed after the invasion began. Britain pledged further supply on March 24th. The RUSI Preliminary Lessons Report, published in 2022 by the Royal United Services Institute, identified anti-tank guided weapons, NLAWs and javelins, as central to Ukraine's early defence. The account of the Battle of Kiev confirms that Ukrainian special units combined anti-tank weapons with ambush tactics against Russian armoured columns. Exactly the close-quarters, rapid engagement scenario the NLAW's 20-metre minimum range and 5-second firing cycle was built for. The US Army's WSTIAC Quarterly summarised the NLAW's designed capability cleanly. The NLAW is touted to knock out any main battle tank by strikes from above. Analysis of the early fighting around Kiev confirmed that Javelin and NLAW guided missiles had not been defeated by active protection systems on Russian vehicles. Total UK anti-tank missile deliveries across all types in 2022 exceeded 6,900 systems. UK military aid to Ukraine in 2022 reached £2.3 billion, more than any nation except the United States. The Sun, the UK tabloid, reported a story in 2022 from a Ukrainian commander in Lviv, who said he would shout, "God save the Queen," before firing the British-supplied NLAWs. That's one commander's statement to one newspaper, and it's worth attributing precisely rather than generalising. But the sentiment it represents is consistent with the broader documented relationship between Ukrainian forces and the pre-invasion delivery timeline that gave them a weapon in hand before the tanks arrived. The UK response to the battlefield performance was continued procurement. The £280 million deal in December 2022, the £223 million Thales-Belfast contract in January 2023, the £229 million DE&S agreement with Saab in 2024 to 25. The Belfast assembly line has run continuously since 2009 and has been at its busiest in the years since the invasion. The last argument worth addressing is one that didn't get a proper answer in the comments, that ATGMs are already obsolete because FPV drones do the same job for a fraction of the cost. The cost differential is real and substantial. FPV drones in Ukrainian service cost roughly $500 all in, including the warhead. A documented Ukrainian strike destroyed a Russian Mi-8 helicopter, a $10 million platform, with one. NLAW unit cost isn't officially published by the UK MOD, but the procurement numbers, £229 million for thousands of systems, imply a per-unit cost somewhere in the £20,000 to £40,000 range. FPV drones are, by any comparison, dramatically cheaper. But the comparison assumes the two systems are competing for identical mission sets. They're not. FPV drones require a radio control signal. They need a pilot maintaining visual or thermal contact with the target throughout the flight. They're vulnerable to GPS denial and RF jamming, both capabilities Russia has deployed extensively in Ukraine. Electronic warfare adaptations specifically targeting FPV control frequencies have been documented in real time by Ukrainian operators. The drone's advantages — cheap, long loiter, remote operator, become liabilities in ECM-saturated environments. A jammed FPV is a $500 piece of debris. A fired NLAW has already committed its energy to the intercept. The NLAW has no RF command link. Guidance is passive and inertial, established in the tracking window before firing. After launch, nothing about the weapon's function depends on the electromagnetic spectrum. Weather, smoke, and electronic countermeasures that ground or defeat drone operations don't affect a missile already in flight under inertial guidance. The US Army Infantry Journal noted in spring 2025 that in Ukraine, drones, along with top-attack ATGMs, gave the Ukrainians advantage, framing the two systems as complementary, not competing. By 2024, both sides had dramatically increased drone use, while also continuing to consume anti-tank missiles at high rates. Neither side stopped buying ATGMs because drones existed. The UK, operating in full awareness of the most drone-intensive conflict in history, signed 3 separate NLAW procurement deals between December 2022 and 2025, committing over £730 million. No NATO military has reduced ATGM procurement specifically because of FPV drones. The organisations responsible for actually fighting these fights are buying both. The drone obsolescence argument makes a reasonable cost comparison and draws the wrong conclusion from it. Drones are highly effective in permissive RF environments. ATGMs are reliable when those environments aren't permissive. In an EW contested fight, which is what any future conventional conflict involving near-peer adversaries almost certainly looks like, the NLAW fills engagements where drones get jammed, grounded, or shot down before reaching the target. They're not the same tool. They don't replace each other. So, the NLAW isn't thermobaric. The warhead is 850 grams of PBX explosive in a 150mm shaped charge configuration, firing a copper liner into a hypervelocity jet that penetrates armor through hydrodynamic pressure. Not heat, not plasma, not burning. The jet tip moves between 20 and 40 times the speed of sound. The copper liner never reaches its own melting point during the process. The armor it penetrates doesn't melt. It temporarily flows under pressure and then stops, having been physically displaced by the jet. The weapon was designed to a British military requirement issued in 1997. Saab Bofors Dynamics won the competition in May 2002 and holds the prime contract. Final assembly happens in Belfast at a French-owned factory under contract to a Swedish manufacturer. The UK has spent well over £700 million on the system since 2022 alone. Sweden operates it as Robot 57. 14 UK subcontractors supply components. The attack modes, overfly top attack and direct attack, exploit a specific armor vulnerability that a thermobaric warhead couldn't reach anyway, because thermobaric warheads can't defeat buttoned-up tanks, regardless of where you aim them. The NLAW may not be the last word in anti-armor. Drones are changing battlefield economics in real time, and nobody serious is pretending otherwise. But it was never thermobaric, it was never purely British, and the Ukrainian soldiers who used it during the defense of Kiev in the spring of 2022 trained on these systems in weeks, firing them against armoured columns at close range, didn't particularly care what the comments section said about its warhead chemistry or its national origin. They cared that it worked. If this is the kind of deep dive you're after, subscribing keeps more of it coming.